Turning setbacks into stepping stones. You don't make progress by waiting for perfect conditions. You move forward by doing something, anything, even if it's messy, flawed, or incomplete. Setbacks are not a deviation from the path. They are the path. Every significant breakthrough in history has come after failure, after people were told something couldn't be done, after the prototypes exploded, malfunctioned, or crashed, sometimes literally. The real world doesn't care about your plans. It throws friction in your face. Budgets get slashed. Technology doesn't scale. Teams fall apart. And everything takes longer than expected. But friction is where momentum is built. Steel is forged under heat. Pressure is necessary. You want to build something meaningful, expect failure. Expect to be wrong. In fact, you should assume that your first few versions will suck. That's normal. But if you iterate fast enough, learn aggressively, and stay insanely focused, those same failures become the scaffolding for success. Most people stop when things get hard. They interpret a failed attempt as the end. That's a miscalculation. Failure is just data. The question is, what are you going to do with that data? Look at systems, understand the root of the failure. Was it a bad assumption, a poor design, misaligned incentives? Fix it, build again, push forward. Do not waste time feeling sorry for yourself. The truth is, people who achieve what seems impossible are just the ones who kept solving problems while everyone else gave up. They didn't wait for permission. They didn't listen when people said, "That's not realistic." They treated every obstacle as a prototype, just another flawed model to improve on. We don't move civilization forward by playing it safe. We don't explore new frontiers by optimizing for comfort. Risk, discomfort, and failure, they're part of the cost of doing something big. If you're not failing, you're not trying hard enough. So treat every setback like a test, a stress test for your idea, for your team, and for yourself. If it breaks, good. You just found a weakness. Now you know where to build stronger. Stop thinking in terms of success or failure. Think in terms of engineering. Input, output, iteration. Strip the ego out of it. Make it work. Then make it better. Turning setbacks into stepping stones isn't a motivational quote. It's a process, and if you're serious about building something that matters, you better master it. Failure is data to use it. In the world of engineering, business, and innovation, failure isn't just a possibility, it's a guarantee. But failure on its own doesn't mean anything unless it's examined, understood, and converted into action. What separates successful people and teams from everyone else isn't the absence of failure, it's what they do after it happens. They don't see failure as the end. They see it as input. When something breaks, that's information. When a strategy falls apart, that's a signal. When a launch goes wrong, when a product underperforms, when an assumption turns out false, every single one of those moments contains a payload of valuable data. But only if you're willing to treat them analytically, not emotionally. This mindset doesn't come naturally. Most people are trained through school, work, and culture to avoid failure at all costs. We're taught to optimize for safety, to avoid looking wrong, to protect our egos. But in doing that, we cut ourselves off from the fastest learning loops available. The real world teaches you by pushing back. If your model doesn't hold up in reality, it's not reality that's wrong, it's the model. That's why the best innovators obsess over feedback loops. They create environments where failure is fast, cheap, and visible. They build, test, fail, and repeat, not because they enjoy failure, but because they know that every failed iteration tightens the loop. Each one brings them closer to a design, strategy, or system that actually works. Think about a rocket launch. If a component fails mid-flight, that's not just a disaster, that's an event packed with telemetry. Engineers want that data. They want every sensor readout, every frame of video, every error log. Why? Because the failure tells a story. It reveals where the stresses were too high, where the materials gave out, where the math didn't line up with reality. And with that story, they go back and build better. The same applies in business, software, manufacturing, product design, even relationships. Failure always contains insight. When you lose a customer, that's data. When a product flops in the market, that's data. when a pitch fails to land, when a team breaks down under pressure, when a deal falls through each one in a puzzle to reverse engineer. It's not just about what went wrong. It's about why it went wrong and what system design allowed that to happen. Failure becomes powerful when you learn to dissect it. That means getting specific. Vague reflection like "I guess we weren't ready" is worthless. You need to be surgical. What hypothesis were you testing? What did the metrics show? What assumptions didn't hold up? What signals did you ignore? What variable did you miscalculate or underestimate? What broke first? What broke next? What did you miss, and how can you make sure you don't miss it next time? This requires emotional detachment. You can't take failure personally if you want to mine it for real insight. That's not easy. People get defensive, teams assign blame, leaders look for excuses. But the more time you spend pointing fingers, the less time you're spending decoding the failure into something useful. Get to the root cause, not just the surface symptom. Strip out ego and narrative. What's the raw mechanism at work? One of the most productive things you can do after a failure is run a post-mortem, not as a punishment, but as an engineering task. You analyze what happened, when it happened, why it happened, and what changes are necessary to reduce the chance of it happening again. You track contributing factors, identify breakdowns in process or communication, and set new constraints or parameters. And then, most importantly, you integrate those findings into the next iteration. That's how systems evolve, not through perfection, but through continuous refinement informed by failure. The danger is in failing and ignoring the data. That's when organizations stall. That's when entrepreneurs burn out. That's when teams get stuck repeating the same mistakes. Because no one took the time to ask the hard questions. Learning from failure isn't passive, it's a discipline. It requires uncomfortable honesty, technical analysis, and the will to adapt. In fast-moving industries, the ability to learn from failure becomes a competitive advantage. If you can move through your feedback loops faster than your competitors, you'll innovate faster. You'll adapt quicker. You'll solve the real problems while others are still trying to avoid the embarrassment of admitting things didn't work. This doesn't mean you should romanticize failure. Failure on its own is not a virtue. It's only valuable when used as a feedback mechanism. Failing repeatedly in the same way is just incompetence. Smart failure, the kind that leads to insight, is strategic. It's the product of deliberate testing, fast prototyping, and data-driven review. It's not a freefall. It's a controlled descent, monitored carefully, and used to guide the next lift off. This is also why speed matters. The longer you delay testing, the more you insulate yourself from the reality check of failure. Teams that delay shipping for years often do so because they're afraid of what the market might say, but hiding from the market won't protect you. It just makes your first real failure more expensive. Get feedback early, fail early, learn early. Your first version should embarrass you a little. If it doesn't, you waited too long to release it. And when the failure happens, don't flinch. Zoom in, understand it, archive the learnings, build the next version with those exact failure points in mind. Make sure the next system, product, or approach directly addresses those weak spots. That's how you turn a failure into a foundation. Data is only useful if you're willing to act on it. And failure is one of the richest data sources you'll ever have. It's unbiased, it's honest, it's ruthless, but if you're listening, it will tell you exactly what you need to hear. Iteration beats perfection. Trying to get something perfect before you launch, it is often just a clever way of procrastinating. The pursuit of perfection sounds noble, but in practice it slows down progress, hides problems, and disconnects you from the feedback that actually matters: reality. If you're not releasing, testing, and iterating, you're not improving. You're just refining assumptions in isolation. The world rewards execution, not potential. A mediocre version in the real world beats a perfect version stuck in your head. The sooner you get something out there, the sooner you start collecting real data, real feedback, real use cases. That's the raw material for actual progress. Perfect is a moving target anyway. What seems perfect in theory will almost always fall apart when exposed to actual use, actual stress, actual unpredictability. This is especially true when you're building something new, a product, a system, a business, a process. You simply can't predict all variables ahead of time. You need to get a prototype into the hands of real users or push a system into a real environment to find out what works and what doesn't. That's not failure. That's the point. Iteration is the process of putting something out there, even in rough shape, seeing what breaks, seeing what sticks, then making it better. Fast cycles of design, test, feedback, and revision allow you to converge on a solution that actually works rather than one that just looks good on paper. The problem with aiming for perfection is that it encourages delay. People spend months polishing features that no one wants. They burn time smoothing edges that might not even matter. They optimize for elegance before they've proven utility. That's backwards. You don't know what to perfect until you've tested the imperfect version. Engineers know this well. Version 1. 0 is never the final version. It's just the first viable test. You ship it, observe, adjust. You push updates. You fix bugs. You refactor code. You simplify. You remove what people didn't use and double down on what surprised you by working better than expected. In that loop, the product becomes more aligned with reality, more useful, more efficient, better. This concept doesn't only apply to code or hardware. It applies to strategy, marketing, hiring, leadership, everything. You don't need the perfect business plan to start a company. You need a direction, an idea worth validating, and a willingness to adapt based on results. You don't need a perfect org chart to build a team. You need the right people solving the right problems and the flexibility to reorganize when the system becomes inefficient. Perfectionism often comes from fear of being judged, fear of failure, fear of releasing something flawed, but those fears are counterproductive. They block momentum. They keep projects in endless cycles of tweaking. They stop you from testing your assumptions against the only thing that matters, the real world. This is why speed matters. Fast iteration beats slow perfection. If you're shipping once a year, you're gambling everything on a single guess. If you're shipping every week, you're constantly course correcting based on new input. You're compressing the feedback loop between action and learning. And over time, that compound learning curve gives you a massive edge over anyone stuck polishing something that hasn't been tested yet. Even large, high-stakes projects benefit from iterative thinking. You don't launch a rocket by guessing every detail will work perfectly the first time. You build subsystems, test them independently, simulate failure, learn from those simulations, then assemble and test again, and even then you expect the unexpected. The point isn't to eliminate all risk. The point is to reduce the risk per iteration and improve resilience through learning. Perfection is brittle. It assumes that once something is right, it stays right. But reality is dynamic. New variables emerge. Conditions change. What's perfect today might be obsolete tomorrow. Iteration keeps you adaptive. It embeds change into your process. You're not just chasing a finish line, you're building a system that evolves. This mindset scales. Whether you're running a 2-person startup or managing a team in a billion-dollar company, iteration is how you discover what actually creates value. Long planning cycles and polished pitches mean nothing if the execution doesn't respond to real data. Customers don't care how long you spent designing something. They care whether it solves their problem. If it doesn't, they leave. If it does, they'll forgive the rough edges. Even in personal development, the iterative approach works. You don't need to be perfect before you start a new habit, take on a leadership role, or try a skill outside your comfort zone. Start badly, get feedback, improve, repeat. Waiting until you're ready is often just a way of avoiding discomfort. But discomfort is a sign that you're growing. Iteration also builds resilience, because if you're constantly testing and learning, then mistakes don't feel like existential threats. They're just part of the process. You try something, it doesn't work, okay, good data, adjust, try again. This removes the drama from failure. It's just a step in the loop. Some of the most successful innovations came from this mindset. Not from the cleanest first version, but from teams and individuals who put something out there early and kept improving. They weren't afraid to look dumb. They weren't obsessed with getting every detail perfect. They just kept moving, kept solving, kept refining. And over time, they built something exceptional, not because they waited to be perfect, but because they got better with every iteration. There's also a compounding effect. Each cycle of iteration doesn't just improve the product, it improves the team, the process, the communication, the tooling. You become more efficient at building, testing, learning. Your ability to identify what matters improves, your sense of timing sharpens, you get faster and smarter, and as this compounds, it creates a massive gap between you and the people still polishing slide decks. None of this means you should be sloppy. It means you should be deliberate about where quality matters most. Not everything needs to be perfect. Focus your energy on what the user or system actually needs. Optimize for what's essential. Ship the rest. Iterate. Then revisit based on evidence, not guesswork. The discipline of iteration isn't about lowering standards, it's about raising the standard of learning. It's about building momentum through cycles of action and feedback. You don't stall waiting for certainty. You act, observe, and adjust. That's how breakthroughs happen. That's how impossible problems become solvable. That's how imperfect ideas become real-world success. Setbacks reveal systems. Weaknesses fix them. Every system, no matter how well designed, has breaking points. Every process, team, product, or strategy operates under constraints. These constraints aren't always visible when things are going smoothly, but the moment pressure increases, when an unexpected event hits. When conditions change, the true robustness of a system is tested. Setbacks don't create weaknesses, they expose them. They shine a light on what was fragile, overlooked, or poorly understood, and that makes them valuable. When a system fails, it's giving you a signal. It's saying, something in the design didn't hold up. That might be a flaw in the technical architecture, a gap in communication, an error in logic, or even a mismatch between goals and execution. Whatever the case, the failure is a diagnostic tool, a full spectrum scan of where things are misaligned. If you're paying attention, setbacks don't just show you what went wrong. They show you how your system responds to pressure, volatility, and change, and that's information you can use. In engineering, failures under stress, whether mechanical, structural, or electrical, aren't treated as random events. They're the result of inputs exceeding design tolerances. If a part snaps under load, that's a clue. Either the material properties were wrong, the stress distribution wasn't calculated correctly, or the design assumed conditions that no longer apply. That's not just a problem, it's an opportunity to recalibrate the assumptions behind the system. The same logic applies outside of engineering. A team that collapses under a tight deadline may be suffering from unclear roles, poor prioritization, or broken communication channels. A product that underperforms in the market might have gaps in user research, flawed value assumptions, or misaligned features. A supply chain that seizes during a crisis is revealing its lack of redundancy, its over-optimization for efficiency at the expense of resilience. None of these setbacks are just bad luck. They're indicators of deeper issues that were always present, just hidden until tested. People often treat setbacks emotionally, interpreting them as personal failure or misfortune, but that mindset misses the point. A setback is feedback from the system you've built. It's telling you what your design failed to account for. Instead of trying to bounce back to the previous state, the smart move is to analyze the failure in detail, break it down, find the assumptions that didn't hold, identify the weak nodes, isolate the choke points, look at what triggered the cascade and what could have interrupted it. Then redesign not around the failure, but through it. This mindset requires brutal honesty. It's easy to patch over the surface issue and call it fixed, but unless the root cause is addressed, the system is still vulnerable. Real improvement comes from tracing the failure back to its origin. That might mean admitting that your processes are too rigid, your team is undertrained, or your strategy was based on outdated models. It's uncomfortable, but the discomfort is a sign that you're doing the real work. Resilient systems aren't the ones that never break. They're the ones that learn from breaking. They evolve, they adapt. They become stronger at the broken places. In software, this principle shows up in fault-tolerant architecture. In biology, it's called antifragility. In aviation, it's embedded in the culture of continuous improvement driven by incident analysis. Across domains, the same truth holds. Setbacks are part of the feedback loop that improves design if you use them. This is why the best teams don't panic when things go wrong. They switch into diagnostic mode. They look at the data. They map the timeline. They reverse engineer the event and study the response. They don't waste energy assigning blame. They want to know why it broke, not who broke it. And once they know, they fix the system at the level of cause, not just effect. In fast-moving environments, waiting for a perfect system is not an option. You have to launch with what you've got, knowing that reality will expose its weaknesses. That's fine as long as you're committed to rapid detection and iteration. The first version of any complex system is just a hypothesis. The real testing begins when it hits the field. That's when friction shows up. That's when you find the edge cases. That's when the elegant architecture meets unpredictable input. And that's when your feedback loop matters most. A critical part of this loop is post-mortem analysis, not the kind that points fingers, but the kind that produces insight. A good post-mortem breaks down what happened, identifies contributing factors, and extracts principles for future design. It's technical, it's disciplined, and it's embedded into the culture of any high-performance operation. When done properly, it doesn't just fix the last failure, it builds a stronger system going forward. This process is scalable. Whether you're running a two-person startup or managing a global operation, setbacks reveal the limits of your design. If you ignore those signals, they'll repeat. If you overreact, you'll waste time fixing symptoms. But if you analyze with clarity and precision, every failure becomes a debugging session for the entire system, and over time, those sessions compound into robustness. Designing for resilience means accepting that you can't predict every scenario, but you can design systems that adapt under pressure. You can build redundancy into critical pathways. You can create escalation protocols. You can train teams to identify failure signals early. You can develop monitoring tools that flag degradation before full breakdown. And when setbacks do happen, you can use them to tune your systems, strengthen your weak links, and rebuild with new constraints in mind. It's also important to design feedback into the system itself. The faster you detect weakness, the faster you can respond. In technical systems, that might mean instrumentation, logs, and alerts. In organizational systems, it means transparency, clear metrics, and a culture that surfaces issues quickly instead of burying them. In both cases, the goal is to make failure visible so it can be addressed before it becomes catastrophic. Weaknesses don't fix themselves. If ignored, they metastasize. They create brittleness. They turn small failures into systemic collapse. The job of a builder, a leader, or a system architect is not to avoid all failure, but to hunt down weak links before they break again. That means being proactive, not reactive. It means stress testing your own systems, inviting pressure before the environment forces it on you. The best systems aren't the ones that last forever unchanged. They're the ones that evolve intelligently in response to setbacks. They internalize the lessons of stress and failure and come back smarter. Whether you're building software, spacecraft, supply chains, or organizations, the same principle applies. When setbacks reveal weaknesses, treat them as design instructions. System is talking to you, fix it. Progress requires discomfort and risk. Growth and comfort do not coexist. Progress is inherently unstable because to create something new, you have to step outside the known, the repeatable, the optimized. You have to move beyond what you've already mastered and expose yourself to things that might not work. That's risk, that's discomfort, and that's where meaningful progress happens. Most people instinctively avoid discomfort. They stay where they feel competent, where the systems are predictable, where outcomes are controlled. But that safety comes with a cost: stagnation. Without friction, there's no pressure to adapt. Without uncertainty, there's no reason to improve. The system, whether it's an individual's mindset, a product, a team, or an organization, stays locked in place until something forces it to change. Waiting for that external force is inefficient. Choosing to walk into discomfort intentionally is how you take control of progress. Discomfort is not failure. It's the stress that comes with stretching beyond your current capacity. It's the signal that you're doing something you haven't mastered yet, which is exactly where learning begins. The first time you try to solve a hard technical problem, pitch a new idea, lead a team, or launch something before it's fully baked, you'll feel the resistance. That feeling isn't a reason to stop. It's a marker that you're pushing your limits. Risk amplifies that effect. When the outcome isn't guaranteed, when you could fail, lose resources, waste time, or damage your reputation, your brain tries to retreat. It wants safety, but safety is the enemy of innovation. You cannot disrupt an industry, invent a new model, or shift the status quo without accepting that the first few steps might be unstable. Progress looks like trial and error, not flawless execution. The problem is that most systems are built to penalize risk. Education trains people to avoid wrong answers. Companies often reward predictable output over bold moves. Culture pushes people to optimize approval, not exploration. But that conditioning is misaligned with how real breakthroughs happen. You don't arrive at the future by coloring inside the lines. You get there by drawing new ones and risking that you're drawing them in the wrong place. Think of any major advancement in history. Technological, scientific, social. Every one of them came with pushback, uncertainty, and criticism. They came from people who were willing to look foolish, to be misunderstood, to spend years on an idea with no guaranteed return. They bet on something that didn't yet exist, and they paid the price in discomfort, but they kept going. Not because they were fearless, but because they were willing to feel the fear and do it anyway. When you embrace discomfort and risk as part of the process, you change your relationship to failure. Failure stops being something to avoid and becomes something to study. It becomes part of the feedback loop. Instead of seeing failure as a signal to retreat, you treat it as a checkpoint. You ask, what did I learn? What did I miss? What can I adjust? That loop is how you convert risk into insight and discomfort into capacity. This doesn't mean taking reckless risks or seeking chaos for its own sake. It means being strategic about the friction you invite. You put yourself in situations where stakes are real, outcomes are uncertain, and results matter. You design experiments that stretch your limits without destroying your runway. You build systems that allow failure without total collapse. That balance between boldness and control is what makes progress sustainable. Teams operate the same way, forming teams are not the ones with zero conflict or complete certainty. They are the ones that can navigate discomfort together, that can disagree, challenge assumptions, question the plan, and still stay aligned on the mission. They can take risks because they trust each other, and they trust each other because they've gone through discomfort together and survived it. In technical development, risk and discomfort are baked into every serious project. When you're building something that hasn't been built before, whether it's a machine, a platform, or an algorithm, there are always unknowns. Things will break, requirements will change, timelines will slip. But instead of trying to eliminate all uncertainty, the best teams build processes that respond to uncertainty. They iterate, they course correct, they redesign in real time based on what reality throws at them. That responsiveness is not possible without a tolerance for discomfort. Leadership, too, is a high-comfort, high-risk role. If you're leading properly, you're constantly making decisions with incomplete information. You're challenging people to do things they haven't done before. You're holding vision and execution in tension, and you're exposing yourself to criticism from all sides. Good leaders don't avoid that discomfort, they move toward it. They make bold calls, admit when they're wrong, and stay focused even when the outcome is unclear. Discomfort also unlocks creativity. Comfort leads to repetition. Discomfort forces invention. When the old methods stop working, when the constraints tighten, when the pressure rises, that's when people start thinking differently. They drop their assumptions, they simplify, they try things they never would have considered under normal conditions, and often those experiments reveal unexpected opportunities, ideas that would have been invisible from inside the comfort zone. Even at a personal level, growth requires friction. You don't become more skilled, more resilient, or more capable by doing the same thing every day. You become better by choosing hard things, failing at them, and returning with more precision. Whether it's learning a new tool, adapting to a new role, or making Heiss takes decision under pressure. Progress comes from engaging directly with discomfort, not avoiding it. People talk about wanting breakthrough results, but they often underestimate the emotional and cognitive toll that breakthroughs require. You have to be okay with being uncomfortable, not occasionally, but regularly. You have to make peace with uncertainty, with being challenged, with not having all the answers. You have to put yourself in rooms where you're not the smartest person, where the questions are harder than the answers, and where progress depends on your willingness to endure ambiguity. Risk and discomfort are not bugs in the system. They are features of progress. They separate those who iterate, evolve, and build from those who observe from the sidelines. If you're not uncomfortable, you're not pushing hard enough. If you're not exposed to risk, you're not building something ambitious enough. If you're always certain, you're not asking hard enough questions. None of this means that discomfort should be constant or unmanaged. Rest and recovery are important. Systems need periods of stability to consolidate gains. But if your default mode is comfort, you're not preparing for the future. You're optimizing for the status quo, and the status quo is always eroding. Markets change, tools evolve, problems mutate, the world keeps moving. To stay relevant, let alone lead, you have to keep adapting. And adaptation begins where comfort ends.